ఇదే బెటర్, అదే ఇదే బెటర్లే. అక్కడ ఎవరు ఉన్నారా ఆపరేట్ చేసి, మళ్ళీ ఏదైనా ప్రాబ్లం అయితే అందుకే ఎవరో ఒకరు ఉండండి, ఫోన్ చేయొచ్చు. అక్కడ ఏదైనా ప్రాబ్లం అయితే ఎవరో ఒకరు ఉండాలి, మరి పరిగెడతారు సిస్టమ్ కనెక్ట్ అవ్వని నేను చెప్పడానికి. నువ్వు వెళ్ళలేకపోతే నీకు తెలుసు కాబట్టి నీకు ఫోన్ చేస్తా, నేను చేసుకుంటా. Shall we start? Am I audible? It is there. You can get it. Okay, you might not know. Okay, there are some websites are there, like to download the 3D models, GrabCAD, Thingiverse. Some websites are there. It is there in my app also. Okay. Yeah, I downloaded from the Thingiverse. I think Thingiverse. 3D printed models, you can get it. Bone, this I have downloaded, and I told you right, for bone and all those things, that is like a scanned models. We can get the tessellations. You can see there is no square type of thing here. That's why I zoomed it here. All are like a triangles only. You cannot find it square type here. Okay. Thing THINGIVERS. Yeah. Yeah, sure. This one, bone. The models which I told you right, you can get it from my website, like this one. So the model which I told you right, like I can't say every model how I designed. I can't go beneath the layer, so tip of the iceberg I can give, but the 3D models you can download it. This is the one, you can download it, okay? And Thingiverse, this is the one, bone, you can get it here. See, this is the one, bone, you can use any bone. There only I get it. And Thingiverse can download only STL files, remember that. There is no CAD model. GrabCAD means, as the name itself, you can get the any CAD models. Whoever the person, like the designer uploaded, suppose if I am the designer, I uploaded the step files, STL files, and if I design in the SolidWorks format, I can upload the SolidWorks format, like that. That's all, that website can take it, okay? So this is the meshed body. So tessellation get confused. So like this it will come, right? So what my objective is to, I need to apply a lattice here. In between I need to apply the lattice. So previously the same thing here also there. Tensile body is there, right? Left, right, middle. Same thing. But this is the STL body. Previously we have designed the CAD body and we have separated in the CAD software itself. But here in NTOP, this is the STL body, and we cannot do the separation in the SolidWorks or CAD software. So we are using the NTOP here. How to do that means, first we will convert into, and I told you right, in NTOP we can play with the implicit body. Once we convert into implicit body, then only we can do whatever the operations, Boolean union or some cutting, subtraction, these things. So first we need to convert into implicit body. Okay. there is an option called implicit. See, this is a meshed body, right? So implicit body from mesh. Okay. So I will import this one, I will drag this one. You can see here, I told you, right? Icon, globe, network symbol, globe symbol is there. Here also globe symbol is there. So this will accept. Or otherwise, double click on it. Available options it will show. Mesh underscore 1 name. Okay. You can get this one. See, it converted into implicit body. See. Previously our body is like this. Now our body is like this. Okay. So now we can do the whatever the operations we can do now. Okay. So first what I will do means I will separate into two bodies. Okay. Like this is left, right, and middle portion like this. It is there actually. It is there like this, and I need to extract the middle body. So what I will do means I will take a planes and I will cut it. With respect to that plane, I will cut it. Like this, I will take a plane. This is the bone is there, right? Like this, some like bread is there and knife is there. We are slicing into like this. We are slicing means it will separate like this, right? Same thing. Means plane I am taking. Your plane normal is there. I am taking like this. I will show you. So what is I told you, right? Entropy is like if you understand the Boolean union, subtract and interaction, then you can understand the entropy. So subtract we will see. Then union we already seen, combining the three separate bodies. Three separate body means that should have a contact. Then only the meaning of the union is had a purpose, right? If the body is one body is here and the other body is here, means there is no purpose of combining actually. Okay, that should have some contact. So once we convert into implicit body, then we can separate the body and we can extract the middle portion. How we can do means, so Boolean subtract. My primary body is this one only. In this only I need to do the operations, right? So that is my primary body. See, icons are there. I can drag it and I can place it here, okay? Remaining blend radius I am not exploring. You can get it in the help also. I will keep this as the same. So what I will do means, I will subtract with the plane. So the subtraction body is the plane. This is the body is there, right? One body is there. And I am applying a subtraction here with respect to this plane. So this body can separate. How? From primary body, okay? So I will take plane from normal is there. Okay. See, your plane is here and this is the implicit body and my plane is here. So I need to drag this plane. Okay. You can keep it. Okay. Okay, we will see how it cut it. See, like this we are getting, right? But I will perform in a one single stroke. I will extract the 3D body. I mean, okay, we will see. So one more plane I will take it. This is the implicit body, right? See, this is removed, and I need to remove from this side also, right? So one more plane we will take it. Plane from normal, or otherwise I will copy the same plane. Control C, Control V, and this one I will see. This symbol is there, right? That is the toggle visibility. Okay. So this plane I will drag this here. So I will be here. Okay. Now we will see how it can. Again we are getting this one, but we are getting the same direction of the plane. See, this plane is in the same direction. This plane is in the same direction, right? So I will change the direction. One direction I can change it. This I will keep -1. I will see. Oh, both the planes are same. Okay. Okay. Okay, minus 1 plus 1. Yeah. See, I am getting the middle portion, right? See, previously this is the one, and I am applying my body here. I am applying, my intention is here only. So the remaining portions are the, this is the design space. Remaining portions are the non-design space. I don't want to apply the lattice there. So I separated here. So you might have a doubt, we can do the same operation in the SolidWorks or other software also. But the problem is, SolidWorks means STL file, we cannot play the STL files, right? So NTOP or Magics, like Mimics, these things only STL file can support. There we can separate the bodies. But I am using the NTOP and I am separating the two bodies, okay? So I will apply the lattice. First what I will do means, this body is there, but the other two bodies I don't have, right? So initial body is there. Again I will take the subtraction from this, okay? You understand, right? Suppose this original body, from this original body, if I separate this body, I can get the remaining two portions, right? I will rename this one bone under bone lattice. Otherwise design space, right? So again Boolean subtract. So my primary body is my original bone. I will take this name as a bone, original. Now just to identify easily, I am renaming this one. So original, if I type bone original, and the subtracted body is the bone design, okay? See, I am getting this one, right? So this is my non-design. Yeah, this is my non-design body, means my lattice won't touch there, okay? Non-design, okay? So I will apply the lattice to the bone design body, this one, okay? Again same thing. See, I already applied here, you can see here. Okay, I will apply once. Let's see. So my volume is that implicit body. Volume obviously implicit body I should apply. So what is the implicit body means? This one. The design body I need to apply. So I will drag it, double press on it so that you will get the available options. So I will use the wall TPMS unit cell. This time we can use the diamond. I will increase the unit cell size. Like 3 mm. Yeah. So I will further increase the unit cell size to get to see the pores. Okay. This each wall is there, right? That is of 3 mm thickness. Okay. So this one is there and this one is there. Now again same thing, same operation. We have completed this tensile operation only. Again once we are getting thing, we can combine the two bodies, right? So Boolean union. There is some one part is there, intersect is there. Intersect means common portion we will get it, okay? So two bodies we need to combine, okay? We have combined the two bodies. And if you want to extend this further, you can increase the plane. Plane, this is there, right? Here planes is there, right? Here one plane is there, here one plane is there, right? See, we are cutting like this, right? We are applying a plane like this, our plane perpendicular is there, and we are moving like this, okay? You can increase the further so that you will get the bone lattice portion is there. I have randomly put the length and all those things. Like this you will get the bone to the lattice body, okay? The same type of design is already available there, you can get it here. Gradient also it is there. So clear? Then if you are clear, then we can go for the engineering component, that is brake pedal. Any doubts is there? Yeah, forgot. Well, like weight saving? Yeah, I forgot. I will do. Yeah, see, weight saving is there, right? That is important finally, because so I will rename this as a bone with lattice. Now why I am renaming this one means later like wait, I will show you one thing. See, yeah, actually this project is there, lattice structure applications is there. There are like some hundreds of designs is there in the file, like it is of 2 GB file is there, hundreds of designs are there. Like if I didn't rename anything means implicit body 1 means it will go like implicit body till 1000 or something. So each one I have renamed the separate file, like some branches something is there, right? So branches body, branches original, branches lattice, like that I need to rename. If I didn't rename means it will go, you will get the confusion while applying the so many operations on these things. That's why I'm like, it is a good practice to rename it actually, okay? So bone with lattice, that is a lightweighted body, right? Bone with lattice. Okay, and the original body is that bone original, I think. Yeah, bone original. Okay. Yeah. In topology actually use the topology optimization, but Fusion 360 will use the generative design. The thing is like right now I am learning that, so I can say this thing. It will use the cloud credits like in AI is there, right? AI, if you want to generate image means we need a prompt. We need to buy the prompts, right? For it is open secret. Like for educational one, if you are using for the educational purpose, you can give the Gmail also. You will get the unlimited credits actually to use the generate design. After 2019, I think they have adapted this one to give the education license unlimited credits. We can use the generative design for Fusion 360, and what I like, as per my information, only Fusion 360 is the one who is using the generative design. Remaining all other software like ANSYS, Abacus and Entop are using the topology optimization only. Only Fusion 360 is using both generative as well as topology optimization. Generative design in Fusion 360, like I am using student version, so I don't know whether that module is there or not, but generative design is there in Fusion 360. It will remove the material, unnecessary material it will remove. Yeah. Yeah, like it, yeah, branches something like bone. Then that is not there in actually here. That you can go for the entopole. I told you right, like MS lattice is there and entopology is there. These are the two one, but in entopology you can play with the surfaces and all those things. In that you can do it in entopology. Like the simulation we can do. Like we can topology optimization will take the load simulation actually. Yeah, as well as generative design also will take the basic idea of generative and topology optimization is that we need to get the best result by taking the, it will take the objective, your objective is to get the good result by maximizing the strength and reduce the weight, and the constraint is that it should not exceed the this much of it should not remove this material, passive region, non-passive region, like the design space, non-design space, and it should not exceed this much of stress, that we can, that these are the constraints actually. According to that, it will generate the design or it will optimize the body, that we call it topology optimization. Algorithms are different, both the things. There generally no actually. That we can do actually. Yeah, after topology optimization, we can incorporate the lattice. I mean, yeah, like I don't know how to say. Like it is like related to my work only. Like that only I did actually. Like after completing the topology optimization, like previously I showed you, right, weight reduction method. These are the some weight reduction methods is there, right? Based on that, I wrote a one paper. Like I took a one bracket is there, and I applied the topology optimization, and I applied the lattice structures, and I combined both topology optimization as well as the lattice structures also. These things I did, and you asked the gradient, right? There also I did actually both uniform as well as the gradient lattice structures I applied. Like I just want to explore the how much is the potentiality of these methods are there and how much weight reduce using these methods. Yeah, 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 yeah. That, yeah, that is the problem. And the simulation part you can do the entop, but the problem is that we cannot trust the entop results, so we are using the abacus explicit analysis. There we did, and I used abacus implicit analysis, static analysis I did actually, not dynamic. Dynamic also, dynamic you can see the real time data, these things we can see. Abacus is good to go for the entop parts to do the simulation. No, but we can apply the like lattice to the topology optimized body. But generative plus lattice structure, it is not there actually. It is not there. I understand. And the thing is, only Fusion 360 have the ability to do the generative designs because it will work on the AI based designs. So it will take the cloud credits and all those things. And education license, it is unlimited. You can explore it if you are applying the education license. And remaining other software is the topology optimization only, as per my information. So that is how you can design the 3D model, and if you are extending this operation, you can go with the you can increase the lattice length and all those things, and the density you can see 13 point, like weight saving is 14%, and if you want to increase the weight saving, what to do? If you want to increase the weight saving, what to do? Suppose, okay, this is the basic actually. How to increase more porosity? Reduce the thickness. If I reduce the thickness, then the component will be lighter, right? So pores will be more, right? Or otherwise increase the lattice size, like some 50 mm cube is there. I am applying 5 by 5 by 5 means how many things I am getting? 10 into 10 into 1000. Suppose if I am applying 10 into 10 into means 5 5 5, 225 will get it. 225 unit cells I will get it, right? So unit cell size get reduced, so the lattice density will get reduced, right? That is how. I mean, these are the parameters you can do the optimization, like how to increase the porosity and all those things. If someone asks means increase the unit cell size, means decrease the number of unit cell size, okay? And the decrease the thickness also there, that also we can do, okay? So that is how we can do the bone. And there is one more option is there, engineering brake pedal is there. I will export it. Okay. Yeah. See again, this also like I told you, right, design space and non-design space is there, right? This is the best example. You can see it here. I will tell you, some holes are there here, but I cannot able to define the design space and I cannot able to cut it actually. That we can do it in end up easily. We will see. And I already separated this body. My intention is to apply the lattice here. So I separated this body in the SolidWorks only. See, in this body I don't want to apply the outer body lattice, right? So I want to apply the boundary region. This boundary I have confined, so I will apply the boundary. I have defined the boundary, I will apply the lattice here, okay? So first what I will do means, we will take this into new section. Close this, okay? First I will convert this into the implicit body, okay? I will rename this one break. This is your design space, okay? And this is, and how to convert into implicit body means, press one time you will get the face. Press again double click on it, you will get the, you will select the entire body, okay? So one time I am selecting the face, right? I am pressing two times, I am getting the entire, I can able to select the entire body. Right click on it, convert create body into implicit body. This is break, non-design space, okay? Okay, now I will apply the lattice. This is the one I will drag it. Acha, you tell me which lattice I should apply, whether I should apply the graph strut based or 2D lattice or TPMS lattice. In TPMS I will ask you the which one I should apply, and you want to see xyroid, okay, that is TPMS then. So wall TPMS, xyroid squash is there, so this I will increase the thickness, otherwise processing time will increase. 15 I will keep, later we can see. And thickness some 2 mm we can see. Oh sorry, non-design I kept, okay, design I need to keep, okay. So we can increase the thickness. See this is how we can get it, but here the problem is that my attention is to complete the body. I can able to get the design, and I can combine this one non-design. Finally I will get this one, but here one problem is there. Can you able to see? Can you able to say? See here, okay, this is a good thing, and here surface is there. See, suppose if I am applying a bolt, means will it able to fit? There is no threads, right? So that we need to define it as a non-design space. How to define means, this we will see the Boolean intersect, here only it will come actually. So again we will go for the imported body. This one is there, right? This I will select it. These two bodies I will select, whole faces I mean. Those two faces I am selecting, and what I am able to see means, I will convert into implicit body. First I told you, right, whatever you want to do the end-top operation, we need to convert into implicit bodies, okay? First I will convert into implicit bodies, and I will thicken the bodies, so that you will see that. Control, select the bodies, okay? Convert CAD faces to implicit bodies, okay? See, total 3 bodies are there. See these 3 bodies, okay? So I can apply the thickness to the faces. These are the surface, right? So I will apply the thickness to the surface, okay? Thicken body. So I will drag this. See, the symbol is same, right? I will drag this. I can apply the thickness 5 mm, okay? This is okay? Wait, we will see now. Design, right? Is this okay? Are we getting like this? See, this is the original design. This is the one we are getting, but the hole is not in proper, right? So here is the one we need to apply the intersect. Intersect means common body, it will remove it. It will find the common body, right? So that we can find it, okay? So Boolean intersect. And see, the thing is, this is not even moving. Why it is not even moving means, this is like a two separate bodies, right? So the best way to say this example means, I am deleting this one. Why I will say, see, I will delete this one. I will take this as a single body, and I will do the Boolean union there. Sorry. See, here you can see three bodies are there here. 1, 2, 3. 3 faces, 3 bodies are there. Thicken. Okay. 3 bodies are there, but 3 bodies are not in the same bag. Okay. We need to keep those in the same bag. Then only we can take it into some other place, right? So how to do this means, first I will take the Boolean union. I will delete this one, because this is as a single body. There is no primary body and secondary bodies. This is as a single body. Those 3 are separated. We need to take that in the single bag, right? So I will take this and delete it. I will drag this one, so that now this will be in the single body, okay? I mean the shape didn't even change. Now that can take it as a single body. Okay? Like this. Now we can export this one. So this one, and the other one is this one. This one and this one, right? Or otherwise this one we can take it. Okay? This is what is the name of this one? I think design or non-design? Yeah, design means the one we are applying, we are able to tweaking of the design, okay? So brake pedal, brake design, I think. Okay? See, we are getting right. Now we will see. So is this okay? We can print it, and we can do the threading operation. We can apply the bolt, and you can see this is there, right? Why we are getting this bolt head is there, right? It depends the thickness. You can change it actually. If you increase the thickness, the bolt head, it depends on the bolt head thickness also. Like that you can change it. That is bone. No. This is actually that spline curves is there, right? Initially it is there like this. See, this curve is there. According to this line, I did actually. This type of operation we can do. Actually, that is like a different part. Like SolidWorks we can do. There we can separate the body using the curved path actually. Splines or other, we can separate the two bodies. That is a, I think, no, step file is there, okay. Actually, I did in the I designed in SolidWorks, and I separated this body in the SolidWorks only. There I did actually. So you will get it there, and you can separate it. Bone means STL, right? So we cannot play STL in the SolidWorks. So that's why I prefer the end top here. Okay. We can combine these these bodies. Which are the bodies? This one. Why we are applying this one? We are getting the non-design and this one. So we can break underscore non-design 2. Okay. So we can combine these 3 bodies now. Boolean union. How many bodies are there? So here 2 is there. You can click on the plus, you can import it, okay? This one, and non-design. Okay. Oh, both non-design applied. Okay. Non-design 2. this one, and this one, yeah, this one, sorry. Okay, now we are getting the final design, right? Our holes are, we can preserve the holes and all those things. The main thing is how to identify the design and non, I mean whatever the terminology is same for the both generative and lattice as well as the topology optimization also. The main thing is the preserved region and non-preserved region. Non-preserved means design space and non-design space. These are the non-design space. Always think about it. Holes are the non-design space because that hole has some purpose. We need to put a bolt on it, and we need to do a threading operation. So that should be in the solid format only. That's why we kept it like that. Okay. So that's all from the NTOP. If you have any doubt, you can ask. Otherwise, we can go for the 3DXpert is there. That we can go it. Any doubt is there? What's that? Foam. It is there actually. Yeah, it is there. Stochastic means Varna, it is there actually. Varna structure we call it as a. It is there actually, I will show. I mean, I didn't explore all these, I forgot to tell all these options actually. Simulation you can do here, I told you right, the simulation structural and these things, static, model, buckling, thermal we can do. Yeah, stochastic you can see here. Their Varna surface is there. On the surface also we can, like whenever the texture we are saying means that will be applied to the surface only. The term we are using texture means that will be applied to the surface bodies only. That is not applied to the 3D body. Okay. Surface lattice means we can apply the texture. Volume lattice means entire body we can apply. Varna we call it as. It is there actually. Varna means random points it will apply that there is no uniformity actually. That we call it as a Varna. Is this okay? I mean, this is not, I put a lattice actually. You cannot able to get the unit cell. I told you right. Varna means that should be in the random position. From one point to one point it will change actually. So if I want to reduce the size means, like this. See, there is no uniformity in this actually. And one more thing is like, I mean it is going beyond, like see here you can see this one, right? The tapered portions is there, right? But that we should not able to get like this. You can see here the tapered portion we need to get exactly means we can go with the Boolean intersect here. I will show you. It is hanging. So can I show this later, like it is system is hanging, because 3DXpert is also there, that I will show. Anyway, some people are there, they are interested to know about the Entop. I will take to the lab and I will show. I will use the same body, so I will combine it. You can save this. Combine. Okay. So is this visible, right? One more print. Okay. Okay. అదే కావాలి. So we can add the component, and the thing is, this is the 3DXpert is the slicing software for the 3D systems machines. 3D we have, since we have a DMP Flex 100 which is supplied by the 3D, you can see the name DMP Flex 100, which is supplied by the 3D system. So they have given the software 3DXpert to generate the tool path to put it in the machine, so that we can slice the 3D model. That we can see it now. So we can, same thing, import the component, like in Entop also same thing. In every slicing software, what are the conditions we are doing means, first we will import the slice, we import it and position the body, and we can we can apply the lattice structure, whether any war, like you know about it, right? When can we apply the lattice structure, whether there is any horizontal bridges or overhangs is there. Since lattice is AM is a layer by layer process, we need a lattice, what we call support structures, right? So there we need a support structures. So first we need to add the 3D printing component, position it and apply the support structures, and we can give the parameters and we can generate it. We can send it to the machine. Okay, send a G code. Okay, first add a 3D component. I will add this. So I will keep the same position. See here. And has already Sir told yesterday about there is a some like this is not for all, like as my knowledge I will say, like because you might industry also, like as per my knowledge, for roller support, roller, like this is roller based AM machine. So what will happen, I will show, I will tell you. See, suppose this is the thing is there, right? I mean I cannot go there. That is like a straight path, right? Suppose this is the roller is there, and my body is like this. Yeah. My body is like this, and this is the roller, right? Suppose I am applying this one like this, there is a more contact is there. Suppose if I am rotating this one, your roller is there. There is very less contact. I am moving here, less contact, less contact. The very starting position, that should be in the less contact actually. Suppose if it is like this, your entire surface is in contact. Like during the very roller is moving like this, this is the first wave or bill plate. The first part touching is very high contact area is there. So the bill get failure. So what they suggested means they will ask you to rotate the body into 5 or 10 degrees so that the contact can reduce. That is the recommended actually. So we can position the body first. I will apply the support structures here so that you will get to know, okay. So one I will keep. Delta Z means height actually, like this. Okay. And Z axis I am rotating some 5 degrees. You can change it here, 5. Okay. I will be okay with this position. Okay. But there is a problem with it. This is an overhang position. I will show you. And why I am applying some particular height to this? Why I need to apply the support? I can print it directly, right? This, that is why. Suppose here I kept it, I have designed with a 10 mm, but your tensile usually ASTM 8 standard tensile sample will be 2.5 to 3 mm thickness is there. Suppose you have designed with 3 mm, you need exactly powder limitation is there. You need exactly 3 mm output or 2.5 to 3 mm output is there. So for that what we are doing means we are adding a support in between. And if you are adding a support means the SLM, like the support structure means the parameters are different and the like heat accumulation is there, right? That will be more, and we can get a good print if we are applying a support, be it a solid body or be it anything. We can apply the support some, but here I kept a one body 1 mm. It is recommended value is 0.3 mm to go for the wire cut TDM. 0.3 mm is enough. Just to apply some different supports I just kept. So support manager I will keep. See, these are the parameters. 30 is there. I can keep it as a 45. Anyway, here no overhang angle is there. So I will keep OK. And this will automatically select the area. You can see here. See, this is automatically select the yellow colored area, right? This will automatically select it actually. So again support manager, see that is the reason we are getting here. See, we are getting the reason, right? So I can apply the support. If I am going with the wire cut EDM means I can apply for the solid support so that I can remove it. But to reduce the post processing time means wire cut EDM, and to reduce the material means I can apply some other material also, like wall type supports and all those things. First I will apply the solid, later we can see the other support. So I can go with the skirt support, that is also solid only. Like in between bases we can apply the skirt support. So I will select this. Solid support. Yeah, skirt here it is there. Okay. Yeah. Since the height is 1, we can tweak this value. I will keep this as 1 since the height is 1, so that we can get the chamfered shape. See, we are getting this chamfered shape, right? Otherwise you can keep with the 2 also, no problem. Like this. We keep this 1. Okay. So this is the one, body support. You can see here, support body. Okay. So for the single body we can apply the slicing to reduce the time. So first we can go for the calculate slices, later we can define our own parameters. First we can slice with the default parameter, later we can define our own parameters. So first we'll go with the default parameters, click OK, and we are applying a 17.4 pH. You can change the material also, titanium and aluminum, cobalt, chromium, whatever the machine can support. So it will scan the path, and once we are completed this calculated slices, then we can change our parameters as a scan path manager. You can see here, scan path manager is there, means we can manage the scan path. So recalculate slices, and again our intention is to apply the anyway you don't need to work out on the parametric optimization on the supports, right? Because we are removing the support. Our main intention is part, right? So our parametric optimization is on the part. So two types is the part as well as solid support. So our intention is to go for the part. You can see here, settings, General parameters means layer thickness we can see here, layer thickness, 30 mm we are keeping, we can calculate the number of slices, 367 I am getting. And hatching parameters, main thing will come here, hatching parameters means scanning related parameters, like scan speed means laser parameters, hatching related means hash distance and the scan pattern, these things we can change it, okay. You can see here, this is like a hexagonal, you can see the thumbnail here, rectangular, and if you want to go for the alternative means chessboard actually, okay. Vertical, these things are vertical, horizontal something is there, strips is there. I mean here how many scanning strategies are there means strips we can do, rectangular we can do, and rectangular alternative means chessboard we can do, island scan strategy we can do, hexagonal we can do, okay. Again strips horizontal, vertical, both these things, double centering we can do. And the side step means distance between the hatch spacing, you can see these are the lines is there, right? Each hatch is there, that will go very fast actually in the during the like printing, you can see the how it is printing. So that is the distance between hatching. Suppose if you want to change this 50 to 45 means we can change it. And strips to, by default it is hexagonal, so I can keep it as a rectangular, alternated means chessboard it is. Yeah, laser parameters you can change it here, part right, yeah, part 100 watts it is there, you can keep it as a 90 watts also, and 1200 mm layer, these are the default parameters we are using for here. And if you want to keep 600 or 1000 you can do that also here. So if I reduce the scan speed, what will happen? I mean apart from the defects and all those things, more time to scan, right? Right. I mean defects you can forget, like after printing only we can see the defect, but printing time we can see in the software itself, right? That is what, it will take more time, but sometimes we need to compromise on the scan speed also, because optimization is there, right? That we need to compromise also, we need to go for the less speed also to get the better for a better relative dense components, okay. Defocusing also we can change it, but usually we usually keep that only, we can change it also. That, yeah, variable parameters we cannot keep it here actually. The thing is, the one more thing you can do means you can arrange the like a what we cards pattern, cards are there, right? Card house is there, right? Arrange it. You can arrange the two different bodies and you can give the parameters for different. Segments means what is the what if? That is not there here actually. Even though it is there, we didn't explore it much. Maybe in the advanced version it is there. We are using the basic version of 3DXpert. Some parameters we didn't even touch also, because our main intention is to print it, and to get the printed means parametric optimization, that should be in the dense component. So that we have completed successfully, and once we get the parameters means we are going for the application point of, like I showed you, right? The brake pedal and hip implant is there, right? Those things we are interested to print it, and we have printed also those things. And the lattice structure, these things we are using. Uh, that is what. Actually, the problem with the lattice structure specifically for the PBF I am saying, not SLM, not anything, powder based technologies. The powder get trapped actually. While using the whatever the lattice you printed, the powder get trapped inside. If you see any paper or research paper or something related to lattice structure, PBF technologies, there must be say unmelted powder. Yeah, partial melted or unmelted, uncentered particles, whatever it is. Uncentered particles are get trapped inside it because the, yeah. Yeah, we get a difficult in start base because the that thing what will happen means during that time this is like a three junctions are there, right? Three junctions are connecting here so that the multiple formation will be higher here, so that the roller axis error we are getting there actually. So we stopped the strut basis. Anyway, our intention is the TPMS because TPMS has a better properties than the strut base. This we have scientifically proved in the we have printed in the FDM lattices. FDM printed we have tested and we have scientifically proved it actually. Yeah, octet, yeah. T- like so I will tell you the example. Suppose if you are taking the same porosity like octet and gyroid or some other TPMS structure with the same porosity, 50% porosity, 50% porosity, I definitely say that, yeah, this is one of my paper also there, like I compared these two. In some properties octet is better, like the same thing actually, octet and gyroid I did. In some properties, and that property is that Young's modulus is there, stiffness is there, right? Octet is better because that is like a stretching dominated. Always remember, like I mean this is like a lattice testing parameters like terminology. Stretching dominated has a better stiffness properties actually compared to bending dominated lattice structures. Yeah, all the TPMS, most of the TPMS are the bending dominated, and for strut based, how we are saying stretching and bending dominated means it depends on the Maxwell's number actually. There is some formula is there for to calculate the Maxwell. Yeah, multiple. So we octet means we have printed very less sizes actually. Mainly BCC we are getting this problem. That time we kept 1 mm I think. Yeah, 1 mm or 1 mm. Hmm? Radius, or we call it a thickness. Dia. No, 1 mm dia, 1 mm dia. Sorry, okay, you are saying, okay, 1 mm dia. Yeah, yeah. And we use it to print for the SLM sample, we are not going beyond like 30 mm cube or something, 18 mm or 21 mm or sometimes 15 mm also. But for FDM, we use it to print 50 mm size lattices actually. Because FDM is yeah, we can easily do whatever the things we want. That is what FDM. Yeah. Yeah, why? How we are saying optimization means there should be some parameter output is there. Right? Based on the output, we are saying this is a good parameter, right? And there are in journals I am saying. I mean, whatever the my knowledge, whatever the my like research, like I found that the researchers focusing on the two output parameters. Some people are working on the relative density or porosity, good dense structure they are applying, or otherwise residual stresses is there. If the same parameter is giving the best dense results, but very higher residual stresses means they will leave the parameter. Both the thing they are calculating. The same parameter is giving acceptable residual stress means they will go for the higher dense structures. The same parameter they will use for the mechanical properties actually. That is how I did also my research. And no. Yeah, okay. That geometry what we are doing means some cube samples is there, right? While doing the optimization, not only we, like everyone will print the cube samples, cubical samples, 5 by 5 by or 10 by 10 by 5 something, 5 mm height only or 2 mm height something. They will print it and they will test the relative density using Archimedes principle, and they will do the microstructure and everything. Using the relative density Archimedes principle, they will find the porosity, external porosity. No, no, no. That you are saying that related to design actually. That solid lattice, solid porous. That in terms of design you are comparing. But in terms of printer point of view, I am saying. But first we need to fix the printer optimization parameters, right? That only we are doing. Printer optimize. Once we optimize the parameters, then we can go for the design parameters actually. No, no, no. You are getting confused. Okay. Even wrappage is also there. Yeah. Hmm. Yeah. Because we are going, I told you right, our aim is to focus on the design actually. Design means we have printed like we means one of my co-scholar is there. He has printed so many lattice structure using the default parameters only. In my case, anyway it is completed. In my case, I did the process parametric optimization using the solid bodies, residual stresses I calculated, and solid mechanical properties I calculated. Later, once everything I got finalized, later I go with the lattices actually. Lattices, and I printed the applications using the lattices actually. That is how I did actually. I carry out actually. But one of my co-scholar is there. He is not worrying about the lattice parameter. He just did the parametric optimization and got one parameter, and he's playing with the design things like different structures he is applying and he is testing, and whichever they getting the best results means Young's modulus as well as the, I mean, you may, if anyone know the lattice structure testing terminology, there is one term is called plateau stress is there. Plateau stress, energy absorption is there. Energy absorption means toughness. In solid body toughness, there energy absorption. Mainly they are using shoe soles is there, right? There they are using lattice structure. Energy absorption, helmets is there. Car crashing test is there, right? There we can use the lattice structures. It already Adidas, I think, yeah, Adidas is there. Already they have printed this lattice structure for aesthetic purpose. They did actually. Some shoe soles is there, right? That they have printed. Oh, that okay. Actually, that video got famous. Like, even one guy is there. The tech guy is there. He promoted that video like airtight ball. It is actually airtight ball. Volleyball. It is there. I think so, right? They have printed using the SLS. Yeah, airtight ball. They call it as a airtight ball, named as a airtight. Wait, I'll show. Oh, I will show that. Yeah, this is the one I think. The volleyball with airtight ball we call it as actually. Sports we can use it. Airtight ball, like the same thing they have printed actually. I mean I got inspired from that only, so I designed this one. Just to say volleyball as well as airtight ball. So okay, we can go for here. So once we fix the parameters, we can say okay, save and close. Okay, okay, again okay. I think for body we have changed the parameter to rectangular, alternated. Okay, this we can see in the slice viewer. Yeah, see this is here hexagonal is there, right? You can see hexagonal shapes is there. Now again rectangular, for now part got started, right? Rectangular this is, and you can see here alternated lines are there. Here like you have seen the chessboard, right? In chessboard, what will happen? Like what we call, whatever the black is there, the surrounding will be always a white, right? Same thing here also there. This line is like this, right? The surrounding line won't be like this. See, perpendicular to this. This one surrounding, black and white chessboard. That's why we call it as a chessboard. It is black and white. Okay, like this. Always perpendicular in that like a hatching pattern will be the perpendicular one. So once we are okay with it, we can send this to print. Anyway, we don't print a single part. We can go with the multiple part. This same type of component is there for your printing also. That time also we can say this thing. We can show you in the build view. Fab3 file, the machine will accept the Fab3 files. So that is the one. Sorry that I focused more on the NTOP, so I cannot able to convey more information on this actually. But I will show one more thing, that I applied the solid lattice, right? I will show the wall type of supports, how can we apply that. I will show. I will delete this, delete support, not region. So wall support, see. But the problem here is internally it is not applying. Wall means outer body only, right? So we need to do some other thing, that I will show you. Add pattern, so that it will add the pattern. Like this it will add the pattern, right? See. And square grid or something we can see, take it. And distance I will keep 2, so that we can get the more. Square shell. Usually prefer cross line or square grid. Okay, this one. Fragmentation means if you apply the fragmentation, there is some gaps is there, see, so that we can easily break it. Okay, the support, we can reduce the post processing time. This is one of the technique, fragmentation. Okay, so we can apply this pattern. Now we can go with the wall support. See, now this is in this we are getting, right? But I don't want this to be a single thin wall, so I can keep this as a create solid wall. Okay, but internally this is the thin wall. Okay, outer body it will create the solid wall. Okay, now these type of supports we can easily break with the pilers also. Pilers are some post processing tail. There is no use of wire cut TDM here. Okay, we can use pilers and we can remove it. Again, once whatever if you change the position also, you need to do the slicing again. Okay, so we have already changed we didn't change the position, but we have changed the support type, right? So again we need to do the calculate slices. Again the same thing, the same story will happen. We calculate slices and scanning parameters, again slicing viewer, these things we can happen. But usually we cannot go for the one sample print. We can fill the build actually. Since we have a less memory of the laptop, so I use it to go like this. But there we can see actually. Any doubts till now, like in NTOP or anywhere? And in this also we can do the lattice also. But this is, I prefer the NTOP only. This we cannot able to control actually. They have given just to whoever don't have the NTOP license, right? There may be some useful for them. For that only they have given. But there is no control option here. So I prefer that NTOP is the better one for lattice generation instead of this. During at the base or at the base we have printed some solid wall actually. That is some tricky is there, like we found it actually. Extra solid wall we have printed actually. Or otherwise we can create a solid wall like I told you, right, tensile sample is there. Some 30 mm cube I want to print a lattice. 1 mm thickness I will add some extra base is there, that I can separate the body. During that time my design space is on the 30 mm and that 1 mm space is the non-design space. I will apply the 30 mm lattice here, non-design space I will combine it, I will print it. So the 31 mm will come. In that 1 mm I can cut it. Right? If you want a, like a polishing thing, you can use that, like a polished one. Like the wire cut itself is a good one actually. In the band, for band side it is not good, but wire cut we can get it. Correct. No, it won't damage. We already tried because that structure is the continuous, right? There is no discontinuity in the structure, right? There is a porous is there, but the wire will pass through the porous only. There is a porous is there, but the structure is the continuous. Like one point is there, it will move like this. I will show you. The TPMS you can see here. The structure is the continuous one, right? I mean, this will connect to other body. Don't get confused. This is a two separate body, mean that will connect to other body actually, the side body. Okay. And you can see, I told you right, the strut formation, we have printed the BCC, the problem with the multiple formation. Here on the BCC you can see. The 4 junction points we are the 4 points we are seeing, right? The 4 points is come in contact with each other. So the specifically they told that for roller based thing be like this, if anything happens that will be a problem actually. So the because of the 4 junction points we are getting a difficulty. In octet we didn't feel like this actually. You can see there, yeah, octet. Because octet is a different thing actually. So because of that only we are getting a problem. So the later we go for the TPMS structures, gyroid, split P, diamond, squares also we can do. These things. That thing you can see, that is TPMS, and hexagonal square reentrant are the 2D lattice. Once I play the video, see the hexagonal is not changing because the other direction parameters is same, right? Okay, and the square simple game how it is changing you can see. Okay, that's how we can do. Any questions? Lattice, frankly speaking, since we don't have, like I can't say this, like since we don't have a measurement to calculate the roughness actually, the device we don't have, so but the thing is, it is a very rough surface. Using the post processing we have improved the surface, that we can say, because we have seen because of the powder intact with the lattice, right? We are getting a higher, like rough surface is there, and sandblasting we applied actually. Once we apply the sandblasting we are getting a, like I did the like morphology images, there I found it actually. There I said this actually. Using the sandblasting you can, that powder intact with this one, right? That we can remove it actually. Sandblasting thing. That is there. Anyway, tomorrow, I think day after tomorrow you will get to see what is and how it will improve the surface roughness, these things, sandblasting. Post processing we can see that. Anything is there? Any questions on N-top or this one? Anyway, N-top I took more time because, okay. No questions? Thank you.